This is section 16 of the C4 notes, integration using partial fractions. We're on page 41 of the booklet. As usual, you will need to pause to take notes, as I will not be pausing during the video to allow you to do so, like I would do so in a lesson. So page 41. Sometimes you get integrations where you would be expected to use partial fractions in order to integrate them. So in some cases, doing the partial fractions will be part A, and we'll use the answer in part B when integrating. In other cases, they'll just expect you to recognise that partial fractions are required. So if it looks like it's a partial fraction question without the integral signs, then treat it as that, do the partial fractions first. So in this case, partial fractions take form A over x plus 1 plus b over x minus 2. Now, to create an identity to allow us to solve, we multiply everything through by the denominator. So the left hand side just becomes x minus 5. The right hand side will be able to get some cancelling. So for the first of the fractions on the right hand side, the x plus 1's cancel. And for the second, the x minus 2's cancel. So we get x minus 5 equals a times x minus 2 plus b times x plus 1. Now we choose convenient x values to give us equations that are easy to solve. So we choose x values that make these brackets 0. So x minus 2 equals 0 gives us x equals 2 as a convenient value. Stick that in. 2 minus 5 is minus 3. 2 minus 2 is 0, 2 plus 1 is 3, so we get 3b, 5 both sides by the 3, b is equal to minus 1. Looking at the other bracket, x plus 1 equals 0, so convenient value would be minus 1. Stick into this side, minus 1 minus 5 is minus 6, minus 1 minus 2 is minus 3a, minus 1 plus 1 is 0 as required. Divide by the minus 3. And a is equal to 2. So instead of integrating the original fraction, we integrate two different fractions. So 2 over x plus 1 minus 1 over x minus 2. And when integrating fractions like this, we want the numerator to be the differential of the denominator. So differentiate x plus 1, we get 1, but we've got 2, so place the 2 with 1 and just move the 2 to the front. X minus 2 differentiates to 1, which we've got at the top, so it matches perfectly. So the first one, the 2 carries down, and it integrates the ln of the denominator. Second one is just simply the ln of denominator, and don't forget your plus c's. And that's part A. Part B. Different sort of partial fractions. Other than that, very, very similar to the last example. Again, we do the partial fractions first. In this case, a over the 2x plus 1. And since the x minus 2 is squared, we need a partial fraction for power of 1 and 1 for the power of 2 to make sure that we get all the right possible terms. Multiply through by the denominator. Left hand side, you just get the numerator. Right hand side, multiply this fraction by that denominator. The 2x plus 1's will cancel. We get a times x minus 2 all squared. For the b, one of the x minus 2's will cancel. So we get 2x plus 1 times x minus 2. And for c, both the x minus 2's cancel. So we get c times 2x plus 1. So we get 2x plus 1 times x minus 2 is 2x plus 1 plus 2x plus 1 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 is 2x plus 1 plus 2 Again, we look for convenient x values. So 2 will cancel out that bracket. So 8 times 2 squared minus 19 times 2 plus 1 is minus 5. 2 minus 2 is 0, cancels. 2 minus 2 is 0, cancels. 4 plus 1, 5c. Divide both sides by the 5 and we get c is equal to minus 1. Look at the other bracket, 2x plus 1, x is minus a half, we'll cancel that out. Stick it into the left hand side. We get 25 over 2. And then stick it into that, minus a half minus 2 is minus 2.5. Squared is 25 over 4a. Minus half into that will cancel, give you 0. Minus half into that give you 0, so those two terms cancel out of the equation. 25 over 2 divided by 25 over 4 will give us 2. And then for these, excuse me, these repeated root questions, we exhausted our convenient values, so we need a third value. If not already used, x equals 0 is convenient to calculate. So we get 1 equals minus 2 all squared 4a plus, put 0 in, 1 times minus 2 times b. Last one, 1 times c. But we know the a and the c, so we can sub those in. 4 times 2 is 8. C is minus 1. So we have 1 equals 7 minus 2b. Add the 2b, take the 1. 2b is equal to 6. Divide by the 2. b is equal to 3. Then we need to integrate our three terms. So we've got the integral of the new fraction, so 2 over 2x plus 1 plus 3 over x minus 2 minus 1 over x minus 2 all squared. Now, the first two are where you differentiate the bottom and look at the top sort of questions and integrate into ln. The third one isn't, so that's a bracket to a power, so we need a slight rearrangement for that one. So x minus 2 to the minus 2 for the last term. Integrating. The first term, differentiate the denominator, we get the numerator, so that's fine. Second one, we don't, we get 1 instead of 3, so move the 3 to the front and replace numerator with 1. Last one uses different rules. So integrating, first one is ln of 2x plus 1. Second one, the 3 carries down, and it's ln of x minus 2. And the last one, it's obeying the rules. So we add 1 to the power, x minus 1 to the minus 1. We divide by the new power, and by the number in front of dx. Well, the number in front of x is just 1, so that'll have no impact. Divide by minus 1, we'll turn that minus into a plus. Please, if you need to, just write down more steps to make sure you're getting it right. Don't forget plus c. And that's our answer to part B. And that concludes this section.